Hey everybody, I want to get started in just a minute, so I'll give a moment for everyone to come join us in the room as we get started for our first gnarly data waves of 2025. Okay, so I'll give everyone a moment to join the room. But yeah, welcome to our first gnarly data waves of 2025, and we will get started in about 20 more seconds. Okay, and here we go. Okay. Hey, everybody, this is Alex Merced, and welcome to our first gnarly data waves of 2025. And today's topic is going to be 10 future developments coming to Apache Iceberg. Okay. This is going to be really cool, talking about things that are kind of coming down the pipeline, some of them really soon, some of them a little bit further down, but exciting things to expect out of Apache Iceberg and that could be enhancing your data lakes and your data lake houses in the very near future. But before we get started, of course, I have some announcements to make. First off, I always want to invite you guys to learn more about Apache Iceberg by downloading a free copy of Apache Iceberg, the Definitive Guide. So if you have not already downloaded a copy of Apache Iceberg, the Definitive Guide, do scan this QR code right now and get yourself a free copy. Okay. Along with that, we have an Apache Iceberg course that you can take. It's 10 sessions of basically Apache Iceberg hands-on lessons, conceptual lessons, whatnot. You can scan this QR code by doing that. You can also do it over there at Dremio University, along with some other coursework that we have, and earn yourself a verified Lakehouse Associate. You have gotten hands-on with Iceberg, DBT, Dremio, and many other tools to really kind of get comfortable with working with data lakehouses, with object storage, and really kind of leveraging your storage as your data warehouse. So you can scan this QR code there to go earn yourself that badge. Okay, so the next question is, what is a lakehouse? Okay, because basically we're talking about sort of where Apache Iceberg fits in. We need to talk about what Apache Iceberg is part of, which is a lakehouse. Okay, and basically a lakehouse is just the next iteration on the paradigm that we've been used to, which is databases and data warehouses. Now, in databases and data warehouses, we've abstracted away things like storage, table format, catalog, processing. So the idea is that we don't think about these things as users of database and data warehouses because these pieces of software hide all these things away from us. Now that makes life really convenient and makes these really much easier to use. But the problem is then every system kind of does it their own way. And now data in one system can't really be used in another system. So you end up having lots of these databases and data warehouses across your different teams in your enterprise. And then when they want to work with the same data, you end up having to make copies of the data across the different systems that different teams use. Whether we're talking about row-based data in a database system or columnar-based data in a data warehouse. So ideally, you would want your data in a place that every team can use the tools that they prefer, but not have to duplicate the data. And this is where sort of the data lakehouse paradigm kind of really comes in. We take a concept we already had as a data lake, which is just a storage layer. So think of like an object storage layer like S3, ADLS, that we can use tools like Dremio and AWS Athena to run queries against the data that we have in those data lakes, whether they're CSV, JSON files, Parquet files, Avro files, work files, etc. So to run queries against all our data. But at that point, it's still not quite like a data warehouse. At the end of the day, like the data in my data lake is still just files. I see like, hey, there's 1,000 Parquet files in this folder. And it's up to me to kind of understand that that's a data set. The interface to the data lake doesn't sort of provide you that because you're interfacing with it as storage. So wouldn't it be nice to be able to interface it with the way you're used to as a data warehouse, where you see tables, and instead of thinking about 1,000 Parquet files, you're thinking about a single table. And this is where a data lakehouse comes in. We take that same storage layer, we take those same data files using the same tools to query it, but now we're going to add in a table format like Apache Iceberg, which allows us to say, hey, I'm not looking at 1,000 Parquet files, I'm looking at a table. And then we're going to have a catalog that allows us to track those tables. So now I can just plug that catalog into my preferred compute tool, which could be, again, a Dremio or AWS Athena or others. And now every team can use the tools that they prefer against the same copy of the data. So you're reducing the amount of duplication of the data, the cost of storage, the cost of the ETL work that does that, and everyone can work a lot faster, and you have much more consistent definitions of your data because you're not having slightly different versions of the data across teams in their proprietary systems. So overall, this is a great way to go. And again, part of that is the table format, which is Apache Iceberg, which is the focus of today's conversation. And Apache Iceberg is essentially just a framework or a specification for writing metadata, which generally writes metadata across 3 different tiers. Okay, we have our metadata files, which basically tell you about the table as a whole, the schema, the partitioning of the table. We have our manifest list, which tells you about a particular version of the table, a snapshot, and says, hey, these are the groups of files that make up the table. And then we have manifests, which are groups of files. And then all these files have metadata that an engine or tool like Dremio can leverage to say, hey, even though this table is 1,000 Parquet files, for this particular query, I only really need 3 of them. And you end up having much faster queries and much faster performance because you're eliminating the number of files that have to be scanned from the particular query. And that's fundamentally what Iceberg provides, is this way to interact with your data as a single table, and to be able to interact with it in a very performant way with the same sort of metadata and benefits and asset guarantees that you would get in a data warehouse. Now that we've established, hey, what is a lakehouse? What is Apache Iceberg? We've level set that. Now let's talk about the future. Okay, so right now you can already build an Apache Iceberg lakehouse. I can have Apache Iceberg tables. I can have them cataloged in a catalog, something like an Apache Polaris that'll track those tables. And then I can connect tools like Dremio, Snowflake, AWS Athena, and a long list of tools to that catalog and run queries against those tables, do write operations against those tables, all with my asset guarantees. That's where we are today. But where would the future of Iceberg come? And that's where we're going to kind of get into these upcoming developments in the Iceberg world. Now, the first one we're talking about is the scan planning endpoint. This is a pretty exciting thing. I actually have a full presentation that I did at a meetup last week just on this topic alone. But essentially what this is going to be an API endpoint added to what's called the REST catalog specification. So let me just kind of like layer this in there. First, there's the REST catalog specification. This is a specification for how you talk to a catalog and how a catalog talks to your tool. And long as both sides, the client, your tool, and the catalog follow the specification, then what happens is that you can use the same sort of way of talking to each other for all catalogs that follow this specification. The beauty of this is that now, instead of having to like create custom integrations with every different Iceberg catalog, you have a single uniform way that tools talk to catalogs, allowing any catalog to work with any tool. But that specification has to make room for the different features that catalogs want to incorporate. So this is one mechanism that's going to be added that basically leaves room for catalogs to innovate, to try new things by abstracting away scan planning. So scan planning is an Iceberg when you go through the metadata and you determine, hey, which files I need to scan. That is usually done by the client. So this would be done like Dremio, AWS Athena. The tool is what actually gets the metadata, uses the metadata to figure out, hey, these are the 5 Parquet files I need. The idea here is to say, hey, why don't we let the catalog do it? Okay, and if the catalog does it, this opens up the room for sort of new innovations, things like scan caching or scan plan caching, meaning you can take for the exact same query, instead of having to rebuild that scan plan every time, you can cache those scan plans. Of course, it'd be like validation checks to see if the tables have changed, but then you can much more quicker return those scan plans because you can cache them. And imagine you run a query in Spark, the plan gets cached, then you run the same exact query in Dremio, and that's going to be extra fast because it doesn't have to recalculate that scan plan because it has a cache from the query in Spark, because the catalog works across all engines. It's going to allow you to possibly query non-Iceberg tables. So imagine being able to take your Iceberg catalog and query Delta or Hoodie tables, or even tables from other databases and data warehouses. These are all theoretical possibilities that catalogs can choose to embrace once you have this REST catalog endpoint added, the scan planning endpoint. It's pretty exciting. There's different ways that it can be used. I'm sure there's all sorts of innovations I haven't even imagined yet that are possible, but it basically creates this space where catalogs can try different things. So that's really cool. Okay, then there's the whole concept of like interoperable views in Apache Iceberg. So right now you do have an Iceberg view spec. So now instead of just storing tables and saying, hey, I have this table, that table, this table, you can store views. And basically a view is really just SQL right now. So now the problem with that is the SQL in different tools is different. So when you store a view in Iceberg, a view that you created in Spark may not work in Athena because the SQL may be different. Okay. So the question is, how do you solve for this? Right now, in the view spec, you have the SQL, and then you do have a dialect property that tells you, hey, this is Dremio SQL, this is Spark SQL. You know, who wrote the view? So you know whose SQL it is. And this theoretically one way to solve this problem is you could use a tool like SQLglot. Okay, SQLglot is a library that allows you to change SQL in one dialect to another dialect. Okay, making it really easy to have SQL that you ran in one place work in another place. You know, within, of course, within limitations. Like there might be features that one tool just doesn't have. But for like basic queries, it can make sure that it translates that for you. And you can use that dialect property to figure out, hey, which dialect am I converting between? Okay, that's possible. That's one option. Okay, but there's a couple other possibilities of how maybe the question should be not do we transpile or translate the view or the SQL? How about we don't save it as SQL to begin with? What if we save it as in some sort of intermediate format, some sort of expression of the relational logic that's going to be executed? Essentially, sort of like the execution plan, okay? Because that's independent of the actual sort of declarative SQL language. So there's a couple different tools you can use for this. Like existing, you have things like Calcite, Apache Calcite, that's been around for a long time. It's used by a lot of tools like Dremio to create these sort of intermediate execution plans to parse SQL and apply these execution plans. Even more newer as an open source project is something called Substrate. And what's cool about Substrate is one that it sends these it saves these execution plans as protobuf, so it's going to be in a much smaller sort of binary package. But also the idea is that it creates a sort of universal way of expressing an execution plan. In that case, any tool that would adopt this standard, this specification, the Substrate specification, can then just take, hey, if you have a view, and then the view, instead of providing you SQL, provides you Substrate, any tool that understands Substrate can just understand that view. They won't necessarily need to, you don't have to transpile an SQL because you'll be using this sort of universal language. So this is something that's being explored. Like, how do you create more interoperable views in Apache Iceberg? But these are some of the selections or options that are being discussed. Materialized views are coming. Okay, the spec has pretty much been adopted and implemented. And essentially the idea here is that now you can have a materialized view in Apache Iceberg once this is fully baked into the library. But the idea is that the way it's going to be represented is through a table and a view. So there was some discussion about like, how do you do this? Like, is a materialized view going to be like a new thing? Okay, because right now you have tables and views, or do you use your existing primitives, which are tables, physical data, or views, logical data, and combine them? And I think the way things have landed is it's a combination of the two. So that way you're not introducing as much new stuff, you're reusing what you have. Because at the end of the day, that's what a view is. A view is, a logical, basically a logical filter on top of a physical table. So the idea here is you would have the view that basically expresses the SQL that defines the materialized view, but then that the data from that SQL does actually get materialized into a separate table that is stored in the catalog. But because you have the view in the table, you know that, hey, this table has this relationship to that SQL. So that way, when you want to refresh the materialized view, you know, hey, this is the SQL I need to refresh it against, and whatnot. So that's something that's coming to Iceberg. And again, the beauty of materialized views and views is just allows us to save and do more of our modeling right there directly in the catalog without having to create new tables at every step, or be able to trigger sort of automatic updates of materialized views we create for acceleration purposes. Okay, and also just as a reminder, if you have any questions along the way, there is a Q&A box that you can put those questions in. Cool. Okay, next is going to be the variant data format. This one's going to be really, really, really cool. Okay, so the idea here is that Iceberg does have a JSON data format. Now, the problem with JSON is when you're traversing these structured data types, is that there's a lot of parsing of text, and then you have to kind of move down this like tree of data, because you have to kind of read the whole object in order to kind of be able to traverse the object. So it can not some for really, really large objects, this may not be as performant as you'd like. Now, variant is a data type that takes the way you express data in JSON, but adds metadata to it. Okay, and it saves it in a binary format with metadata. Okay, so basically you're going to end up using a lot less space to save that same JSON object, but then you're going to have metadata paired with it to help better understand the object and create faster. And I think right now, like there's like two slightly different variations of the variant data type, one in Spark, one in Snowflake. I think the Spark version of that specification is what's being adopted into Iceberg, but it cannot be adopted into Iceberg until it's adopted into Parquet. So basically, that's the big thing that'll enable this to be part of Iceberg, because since Iceberg, generally Iceberg tables are built on Parquet data files, it needs any data type it supports to be something that Parquet supports, which is essentially going to be the same conversation we have on the very next slide about geospatial data types in Apache Iceberg. So the idea is that in the future, you will have geographic data in Iceberg. But again, the big holdup there is making sure that the data type is adopted into the standard Parquet. Like there is a separate like geo Parquet thing that exists as I think a slightly different version of geospatial types. That's going to be slightly different than what's being adopted into Parquet or planned to be adopted into Parquet. But again, once it's adopted into Parquet, that data type, then Apache Iceberg tables can then support that data type. So you have a couple new data types that'll allow you to kind of store differing data than you could have before. So you basically can store semi-structured data like JSON much faster with variant. You'll be able to store more geospatial type data and run geospatial type queries more directly on your Iceberg data using this type of data support. So you got some pretty interesting things coming down the pipeline there that really expand your ability to use Iceberg to the fullest. Now, some of these upcoming things are not necessarily changes to the Iceberg project, but changes to projects adjacent to Iceberg. For example, Apache Polaris federated catalogs. Okay, so right now, Apache Polaris, which is an Iceberg catalog, it has this feature called external catalogs. What that means is that you have internal catalogs, which are catalogs that Polaris manages, which you can read and write to. And then you can connect external catalogs, like let's say you have another Nessie catalog or another Gravitino catalog you're using somewhere else in the company. You can connect that into Polaris so you can view and query those tables, but that's more read only. The hope is to make that a full-blown federated catalogs where all the catalogs, even your external ones, can be connected to Polaris, and you'll be able to read and write from a single catalog connection. So even if you have other catalogs in other parts of the company, you can connect them all to one central sort of Polaris interface. And then that way, instead of having to make multiple catalog connections in my tools, I just connect to Polaris, and all my Iceberg tables across all my internal and external catalogs are visible, can be written to, and read from. So that'll be really, really cool because it just simplifies the process. Because chances are you might have a situation where you have different data teams with different catalogs, if they're managing their own data lakes, if they have separate data lakes. But you want to make it easier to share and unify that Iceberg data. Okay, table maintenance. This is an upcoming bit in Iceberg that's being discussed and sort of hashed out the spec. But the idea is that allowing the Apache Iceberg catalog to be able to generate notifications for maintenance purposes. So imagine this: you use a tool like Dremio to do your table optimization, and you want certain tables to be optimized when they change. So now a tool like Dremio could subscribe to these notifications from the Polaris catalog and know exactly when they change, and even have maybe include some instructions on what that maintenance should look like. Okay, and so now you can grab those directions and then manage the maintenance for your table and basically as things change. So instead of having to set it like a set time, like, hey, run maintenance every hour, which may be too much, so you're running compute you don't need to run that job every hour. You say, hey, when things change, check the notifications based on the rules in those notifications, apply maintenance as needed. So you end up running a lot less compute because you're only running that maintenance when you really truly need to run that maintenance. So that can be, and the thing is that any engine could subscribe to those notifications. So allowing Polaris not to be the place that actually does the maintenance, but to offer a broadcast that allows other tools to be able to leverage it to better execute maintenance. Okay, another discussion is some sort of versioning in Apache Polaris. So it may not be catalog versioning, maybe like transaction versioning, whatnot, but there's still an ongoing conversation of hey, could there be some sort of versioning abstraction in Iceberg at a level higher than the table? Okay, so that way you're not to make it more ergonomic to isolate transactions, do multi-table transactions, and whatnot. So that way, if I want to say, hey, I want to roll back a transaction and roll back all the changes that occurred in that transaction, you can do some more easy. Now, what does that look like? Again, a lot of the developers that are in Apache Polaris were also developers who worked on another catalog called Nessie, which had catalog versioning. That was one approach. So the conversation is like, hey, is that the right approach, or is there a different approach that's better suited? But it's an ongoing conversation. Okay, another really interesting one. This kind of comes out of the Databricks acquisition of Tabular, where now there's this basically discussions between the Delta Lake and Iceberg community to agree that, hey, what, we're better off if the primitives of a lot of these like little building blocks of both formats are similar. Okay, it just makes it more interoperable. Where the building block of one format is better, the other format should adopt it. And one of these is deletion vector. So basically, right now, Iceberg uses a delete file. So you create a separate file, which can be a lot of different files that track the different records that were removed from what's called a merge on read type write. Meaning, instead of writing new files for every delete, what you did is you kept the existing files and just tracked the deleted records in these separate delete files, which in turn slow down a read because a read then has to reconcile these files. So typically what you do is you run regular compaction and maintenance to clean up those files periodically, and then everything's fine. But the idea is with the deletion vectors proposal is that you store them in, instead of having a bunch of different delete files, you store instead of each delete file would become a deletion vector. So, basically a list of records, and they'd be stored in one file, the puffin file, which is a binary standard for Iceberg that stores extra information of all different types. So you can store in the puffin file all these different deletion vectors in binary. So it's going to take up a lot less space, and they'll be in one file, making it much quicker because you're not opening up as many files. So theoretically can speed up this sort of merge on read process, which can be very beneficial, especially for like streaming upserts and things like that. So this is a thing that's being discussed and probably implemented in the future, but it's like the first step. So basically, you're starting to see this collaboration between these communities, not only there, but a lot of the updates to the Parquet data types. Because the idea is like, again, things like variant, all table formats benefit when the Parquet data format, file format improves, because they all use the Parquet file format as their primitive of how they store data. So there's more and more sort of community collaboration around these sort of underlying primitives that make these formats work. Okay, which is, I just want to clarify, is different than a merging of, because you'll hear a lot of people throw that out. It's like, oh, they're all like merging. They're not. Just because like the fundamental way each one is designed and the fundamental sort of use cases and sort of, and also just sort of like there's a lot of fundamental things that are unique and will continue to be unique among each format. But again, there's a lot of places where they can benefit from adopting ideas from each other. Okay, and then you're starting to see more of that. Okay, now also another really exciting thing is the general availability of Dremio Hybrid Catalog, which should come sometime, hopefully this year. Okay, that's gonna be pretty exciting. Now, if you haven't heard about it, currently this is in private preview. And what this is a Polaris-based catalog, managed catalog, that can track your Iceberg tables that you may have in the cloud services like S3 and or ADLS, but also on-prem, whether it's your own private cloud, a on-prem like MinIO server. Basically, your Iceberg tables, so for those who are doing hybrid data lakehouses, which is becoming more and more of a thing, because there's different reasons you may want to have data on-prem, especially when it comes to like AI, where you might want to have a lot of data sort of physically co-located with where you're doing your training compute. This offers you a catalog that can track all those tables sort of in one catalog. Also offer the auto optimization, which generally there really isn't a managed hybrid option, or there isn't really an on-prem managed offering for Iceberg catalogs at the moment. So this sort of provides you a way to have that sort of managed catalog experience on-prem or in a hybrid situation. So that is on the way. Again, it's currently in private preview. You can always contact Dremio if you're interested in participating in the private preview or the next stages of the preview. But that's going to be something that will open up a much better Iceberg experience for a lot of data lakes that are not just cloud only. But those are 10 things that are coming to Iceberg over the next time. Again, a lot of this requires community consensus, so these discussions are ongoing, and the exact moments that they become adopted is always a question. But again, you can get started getting hands-on with Iceberg today, and you can do that by scanning any of these QR codes, which will take you to different exercises where you can spin up a data lakehouse on your laptop today and actually see the whole end-to-end experience right there from your laptop. Along with that, make sure to subscribe to Gnarly Data Waves so that way you never miss an episode. You can subscribe to on either by subscribing to Dremio's YouTube channel over there at youtube.com/Dremio. You can head over to Spotify or iTunes and subscribe to Gnarly Data Waves and enjoy the show. And that way you never miss an episode. But with that, I will see you all next time for more great Gnarly Data Waves goodness, and I'll see you all later.